Hello students, welcome to Learner's Planet Theory Session 2 of Metals and Non-Metals. In our previous session, we discussed about the physical properties of metals like their electrical conductivity, heat conductivity, about their hardness, about their luster and all the physical properties. Now in this session we will discuss about the chemical properties of metals. Let's take up the first chemical property of metal. Now this is, children, electronic configuration. Now we know that metals have so and so properties, that these are very hard, they are not brittle, they are conducting electric current and so on and so forth. But that property depends on the electronic configuration. They usually have 1, 2 or 3 electrons in their valence shell. One of the example is given here, that is sodium. Its atomic number is 11. Its electronic configuration is 281. Let's take up one more example of which example we are going to take, children. Let's take up the example of magnesium. What is its atomic number? It is 12. What will be its electronic configuration? Just tell me, how will you arrange 12 electrons? It would be 2, 8 and 2. Let's take up the next metal, that is aluminium. Its atomic number is 13. What will be its electronic configuration, children? It would be 2, 8 and 3. Now in this group there is aluminium as a metal. How many elements are present in the 13th group? That is boron, aluminium, gallium, indium and thallium. So the metallic character on moving down the group increases. Now if I take the example of carbon, what is the atomic number of carbon? Just tell me. It is 6. What would be its electronic configuration, children? It would be 2 and 4. How many electrons are there here? 4. So can it lose its 4 electrons easily? Because metals have one characteristic feature, that they lose electrons. They are electropositive elements. Can it lose these 4 electrons? No. For losing 4 electrons it requires a large amount of energy. So carbon can be categorized as a non-metal. So for an element to be a metal, what all is essential is, it should be electropositive. That is, it should have the ability to lose electrons. Now lead, though lead has 4 electrons in its outermost orbit, but still it is a metal. Why? Because its size is more. I will explain you here that we have got carbon, silicon, germanium, tin, Sn and lead. Now in this group, children, these two are what? Metals. These are metalloids, or your germanium is a metalloid. And carbon and silicon are what, children? These are non-metals. Now I have told you that metals are what? Are electropositive elements. Now what do you mean by an electropositive element? That it is forming a positive ion. That is, your metal is giving out electron and it is forming a positive ion. So carbon has got how many electrons in its outermost orbit? 4. Rather, this whole group has how many valence electrons? 4 valence electrons. Now, why carbon is a non-metal and lead is a metal? I'll tell you here. Carbon, the shape goes on. The size is this. Suppose, let's take up the another one, that is silicon. Its size becomes a bit bigger. This is bigger than carbon. Let's take another one, that is germanium. It would be what? Still bigger. How much bigger? It would be much bigger than silicon. Clear, children? Now we have got tin, that is Sn. What will be the size of Sn? Sn would be, again, I'll draw it here only so that you are understanding it related to the sizes. Silicon is still bigger. Let's take up lead, that is Pb. So what would be the size of Pb, children? It would be much more bigger atom. It will have much more bigger atom. Now what are we finding here? That the size of atom of elements, what is happening to the size of atom of elements, children? It is increasing down the group. Increases. Where it is increasing? Down the group. Right, children? So what will happen? We have got nucleus at the center. That is, we have got this nucleus here. We have got the nucleus in the center. Right, children? So what this nucleus is having? Nucleus is having a proton. Now what about that proton? Those protons, they exert attractive force on the valence electrons. So nucleus, they have got protons. Protons are what type of charge, children? They are positively charged. Now what these positive charged protons will do? They will attract electrons. Now we can see here that gradually the sizes are increasing. Got my point, children? So when the sizes are increasing, what will happen to the attractive force by proton? More is the size. See, here there is protons, here there are protons, here there are protons, here there are protons, and here there are protons. In which case the force of attraction of protons would be maximum? In this case. So there is maximum force of attraction. In which case it would be least force of attraction? In this case. Why? Why? Because the size of atom is more. Am I clear? Least force of attraction. So what is happening? This will have least force of attraction on these electrons. So your lead, what lead can do? Lead can lose 2 electrons and form your plumbous ion, or it can lose 4 electrons and form plumbic ion. But if I see the case of carbon, This has got maximum force of attraction. Can it lose electrons? No. So that is why I told you that while moving down the group, what is happening? Non-metallic character. Metalloid means metal and non-metal both, and metals, that is having the characteristic of metals. Clear, children? In this case, which ion would be more stable? Plumbic or plumbous? Plumbous, because it can easily lose 2 electrons. Now let's move back to our slides. The electronic configuration. This is how it is decided whether the substance is a metal or a non-metal. Let's take up its next property, that is ionization. What do you mean by ionization, children? Ionization is the formation of ions. It can be positive ion or it can be the negative ion. Now here in this case, sodium, 0 is why? Because there is no charge on it. This is sodium metal. What it is doing? It is losing 1 electron. That is, there is a minus sign here. And we are getting what? Na plus ion. Calcium. It is losing how many electrons, children? 2 electron. And what type of ion it is forming? 2 plus. Right? Likewise, your aluminium. This will lose 3 electrons and will form aluminium 3 plus ions. Clear? So, these are forming what type of ions? Electropositive ions. Now let's take up the next property. Type of compounds. They form ionic compounds. Now what are ionic compounds? These are also called as electrovalent compounds. Now what are ionic compounds? These are the compounds where ionic bonds are present. So in ionic compounds, what type of bonds are present? They are ionic bonds. Now, how these ionic bonds are formed? It is bond formed by transfer of electrons from the atom of an element to the atom of another element is called ionic bond or electrovalent bond. I'll elaborate this with an example. Say, formation of magnesium chloride, MgCl2. What is magnesium, children? It is a metal. What type of ion this magnesium is going to form? It will form Mg2 plus ion, and it will give out 2 electrons. Now chlorine. Chlorine, how many electrons chlorine is having in its outermost orbit? Its atomic number is 17. So it can be arranged as 2, 8 and 7. Now what about this, children? Can it lose 7 electrons? No. Rather, what it can do is, it can gain 1 electron. So, it can gain an electron, and what it can do is complete its octet. After gaining 1 electron, what will be the configuration of chlorine? 2, 8 and 8. So, what can be done is, magnesium is losing 2 electrons. So, chlorine can gain its electron. So what happens here is that Cl, what it does is, it takes up an electron and forms what? Cl minus ion. Why minus, children? Because in this ion, how many protons are there? You must be knowing that in an atom there are protons and neutrons. Protons are present in the nucleus and electrons are present surrounding it. The number of protons is equal to the number of electrons. In a neutral atom, the number of protons is equal to the number of electrons. Okay? Now children, as it is equal, so how many protons and electrons would have been in chlorine? It should have been 17 and 17. Now in chlorine ion, what it has done? It has accepted one electron. So, how many protons and electrons it will have? It will have 17 protons and 1 electron it has gained. So, it will have 18 electrons. That is why we put a negative charge over here. Am I clear? Then this magnesium 2 plus and 2 Cl minus ions will combine and form what? Magnesium chloride. So this type of bond, which is formed by transfer of electrons, is called as what? Ionic bond or electrovalent bond. Here the electron has been transferred from magnesium to chlorine. Clear, children? So this type of compounds are formed by metals. Let's take up its another property. Right, there is electrolysis. Do you know what is electrolysis? I'll show you. I told you this, I suppose, in the manufacture of sodium chloride. Let's do it again. Say, I am taking this electrolytic container in which I have to carry out the electrolysis. So what I'll write here? Electrolytic vessel or container. Okay, children. Now this has got what? 2 rods dipped in it. They are formed of what, children? They are formed of graphite. One of the rods is connected to the positive terminal of the battery and another is connected to the negative terminal of the battery. Clear, children? Now in this case, the one which is connected to the positive terminal is called as what? Anode. Okay, so I'll write it here. Positive electrode is what, children? It is anode. And negative electrode is cathode. Now in this container, what is taken is an electrolyte. If I am taking an electrolyte called as NaCl, so this will form on passing electric current. I have connected it to the battery terminal. So on passing electric current, what will happen, students? This NaCl will be dissociated, forming Na plus and Cl minus ions. Am I clear? Na is a metal, so it will form what type of ions? Positive ions. Right? Now what will happen to the positive ion? This Na plus will get deposited at the negative electrode. Clear? Hydrogen, it also gets deposited at the negative electrode. Right, children? So that is what it is saying. Metals are always deposited at cathode. What about the non-metal? Chlorine is a non-metal. Why? Because it is forming negative ions. Are you getting my point? So, as it is a non-metal, where it will be deposited? It will be deposited at anode. So, this is about electrolysis. Now, there is, children, another point, that is a redox reaction. What do you mean by redox reaction? It is a reaction where oxidation and reduction take place simultaneously. So, these metals, what are they doing, children? They are losing electrons. So, what is oxidation? Let's revise this. What is oxidation, children? Oxidation is, I told you this in our first topic, oxidation. It is either gaining oxygen, right, or what, student? Losing of electrons. So what are your metals doing? That is sodium or potassium or aluminium. What are they doing? They are losing electrons. Right? Like for the formation of aluminium chloride, what will be done is, aluminium will lose 3 electrons and it will form what? Aluminium 3 plus ions, right? And your chlorine will gain electron and it will form Cl minus ion. Now here, what is losing electron? Aluminium. So we can say that aluminium is oxidized. Which one is gaining electrons? Chlorine. So we can say that chlorine is reduced. Right? So, what type of agent is aluminium here? It is a reducing agent. That is, it is reducing others. Right? So, metals are what? Are good reducing agents. Clear, children? So, as metals are losing electrons, so they are very good reducing agents. Now, let's take up the next property. Reactions. Let's now move to the chemical reactions of metals. Reaction of metals with oxygen. When metals are burnt in air, they react with oxygen of air, forming metal oxides. So any compound, what is the name of the compound which is formed with oxygen? It is oxide, children. Always a compound of a substance with an oxygen or with oxygen is oxide. Now the nature of their oxides, we'll discuss it later also. They are generally basic oxides. What do you mean by basic oxides? That is, when I am dissolving metal oxide in water, what will happen? It will form a base, right? That is why they are called as basic oxides. Some of the oxides are amphoteric in nature, like aluminium oxide, zinc oxide, lead oxide. Do you know what is amphoteric? What is it? These are amphoteric substances. These are the substances or the compounds which can react with an acid as well as with a base. Right? So there are substances which react only with acid or they react only with a base. But amphoteric means a compound can react with an acid as well as a base, forming salt. and evolving hydrogen. Let's take a few reactions here, children. Reaction of metals with oxygen. Sodium metal reacts with oxygen of air to form basic oxide, that is sodium oxide. Here there is sodium metal reacting with oxygen gas. I'll write it here. This is sodium solid. This is reacting with oxygen gas, forming sodium oxide solid. Now our next reaction is potassium also reacts with oxygen of air, forming a basic oxide, that is potassium oxide. So the products are the same. Potassium also forms potassium superoxide, that is KO2. So children, potassium on burning with oxygen also forms what? Potassium superoxide, that is KO2. Okay. Now there is next point, that is potassium and sodium react with oxygen vigorously. Vigorously means with a violence. They evolve large amount of heat. So they catch fire. When they are catching fire, where should they be stored? If I am storing them simply like if I am keeping them in a simple bottle, and if at all they are exposed to air, what will happen? They will react with air vigorously and evolve a large amount of heat. So where this sodium and potassium are stored? They are stored in kerosene oil. Let's take a few more examples. Magnesium, zinc, iron does not react with oxygen at room temperature. They react with oxygen at high temperatures. That is like your sodium and potassium, which is reacting with oxygen even at the room temperature, whereas your magnesium and iron, they react with oxygen only at very high temperatures. So magnesium reacts with oxygen, giving you what? Magnesium oxide. Likewise, zinc reacts with oxygen, giving zinc oxide. So this reaction takes place at high temperature. So children, which is more reactive? Sodium and potassium, and rest are less reactive with oxygen. Now in this case, copper metal reacts with oxygen on prolonged heating. Even if you have increased the temperature, then also what happens, that it will react with oxygen if you are heating it for a long time. It's not that when you are subjecting copper to oxygen and raising the temperature to some 800 degrees centigrade and just removing out, copper is not going to react. It will react only on prolonged heating. And what it forms, children, is cuprous oxide. This is also called as copper 2 oxide. Copper 1 oxide, sorry. It should be copper 1 oxide. Copper 2 oxide is cupric oxide. So now I'll conclude this session. In our next session, we will discuss few more chemical reactions of metals.